All right, everybody. Today our lesson is on similar solids, and it's a very similar lesson to similar figures, which was, I believe, section 5. And of course, you know that things that are similar, they're not congruent. They're the same shape, but not the same size. So those are our first two fill in the blank words. Similar solids have exactly the same shape, but not the same size. Okay. And so we know that things are similar if they're proportional. And so in order to find out if they're proportional, we find if they have the same ratio. So two solids are similar if the ratio of their corresponding linear measurements are equal. Okay. So if you think about it, when we were doing similar figures, right, two-dimensional figures, we would check the sides of the figures and create ratios. And so we're essentially doing the same thing, but now we're choosing different parts of our 3D figures. Okay, so types of linear measurements as just a fancy vocab word for things like the length, the width, the height, things like slant height, right? So these things that we use for our 3D figures. We could also use perimeter and um, radius and diameter. Things like the circumference, right? The perimeter of a circle. Okay, so those are just some examples of linear measurements, right? It's linear. That means that the units are to the first power, right? So meter, not metered squared. Okay, so determine whether the solids below are similar. If yes, give a scale factor in simplest form. Okay, so let's create a ratio of the corresponding measurements. So if I choose the height of the pyramid, I would put 12 over 3, right? Because those heights are the corresponding parts. And I'm comparing that to the width, 8 over 2, and the length, 20 over 5. Okay, so if these all reduce to be the same thing, um, then they are similar. So 12 to 3 is 4 to 1. 8 to 2, 4 to 1. 20 to 5 is 4 to 1. So yes. Okay, and the scale factor in simplest form would be 4 to 1. Okay, so that's our answer here. Okay, so I'll do another one of these with you. Number 2, we will compare um, the smaller 6-foot width to 10. The length is 6 to 10, and the height is 8 to 12. Right, so this would be 3/5, and 2/3. Okay, so obviously they're not the same here, so they're not similar. I guess I could just put no. That would make more sense. It does say state yes or no. All right, so you guys can do number 3. Don't let it trick you. You're going to have to double this here to get the diameter. Okay, so if we're comparing volume and surface area, you can actually figure out if they are similar using this as well. It says if two solids are similar with a scale factor of A to B, right? That's what we just did. We wrote our scale factor in A to B form. Then their volume and surface area ratios are A squared to B squared and A cubed to B cubed. Okay, so hopefully this isn't too confusing of a concept for you. We have surface area, right? If you think of area, your units are squared. And if you think of volume, your units are cubed. So let's go ahead and apply this. So it says identify the scale factors and ratios for the similar solids. So they're telling us that they're similar. We're going to create some ratios to figure out the scale factor. Okay, so let's choose the height of the triangle, 6 to 3. Okay, that should be the same as the height of the prism, which would be 10 to 5, and 14 to 7, the base. Okay, so the scale factor here is 2 to 1. Hopefully that's pretty easy to see, right? These all reduce to 2 to 1. So the surface area ratio would be these numbers squared. So 2 squared is 4, and 1 squared is 1, right? And if it's the volume ratio, we cube these numbers. So we would cube these, and we would do 2 cubed is 8, and 1 cubed is still 1. Okay. Hopefully that's not too confusing. I know that one wasn't a good example with the scale factor of 1. I'll do another example. Number 6 says if you are finding, so when you're given surface area or volume, find the scale factor first. So we're going to work backwards here a little bit. Okay, so the surface area of the larger triangular pyramid is 25 feet squared, and the surface area of the smaller triangular pyramid is 4 feet squared. Okay, so this we're comparing 25 to 4. That's what's given, and it's the surface area ratio, right? 25 to 4. Okay, so if we're working backwards from there, it's like taking the square root, right? So whatever our scale factor is, we should be able to square both numbers and get 25 and 4. Okay, so the scale factor is 5 to 2. Okay, and so then after we have the scale factor, we can figure out the volume. 5 cubed, 5 times 5 times 5 is 125, and 2 cubed is 8. Okay, so hopefully that wasn't too confusing. I'll do number 8, and you guys can try number 7. So they give us the surface area again. We'll compare these because I have a feeling we're going to have to reduce first. This 960 to 375, those are not perfect squares, so let's just try to reduce it. We'll get my calculator. 960 divided by 8. Oh, where'd it go? This is 120. Well, that worked. Let's try something else. 960 divided by 16. 60. That's not a perfect square either. 960 divided by 14. Nope. 960. 60 and 8 worked. Let's try 64. Okay, so maybe 15. Well, that would make sense because 375 is probably divisible by 15. So 375 divided by 15 is 25. Okay, so we found it. I'm dividing everything by 15. And that gives me 64, and it was 25, right? Okay, well that's handy because that's the surface area ratio, 64 to 25. So basically what I just did was try dividing it by numbers until I could find perfect squares. And so that way I'm able to take the square root to find the scale factor, right? That's 8 to 5. Okay, and now I'm going to cube 8. So 8 times 8 times 8 is 512. I know you don't have that memorized, but I do. And 5 times 5 times 5 is 125. Okay. But you would have it memorized if you had taken regular 8th grade math. That's something that's required for them to learn. Okay. So let's try some of the word problems. Number 9. Solid A is similar to solid B. The ratio of the height of solid A to the height of solid B is 7 to 3. Find the ratio of the volume. Okay. Well, this one's pretty easy. It says A to B is 7 to 3. Okay. So if it's the volume, right, this is linear. His height is linear. If they want the volume, we're going to find A cubed to B cubed, and that would be 343 to 27. Right, so I just cubed A and B. Okay, and I'll try number 12 and leave you guys 10 and 11. So pyramid A to pyramid B are similar. Pyramid A has a volume of 648, and pyramid B has a volume of 1029. What is the ratio of the surface area? Okay, so we're going to have to use what they gave us, A to B. So that's 648 to 1029. Let's reduce this. Okay, and we're looking for things that are perfect cubes, right? They gave us the volume. I'll go ahead and write some of the perfect cubes down. So 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000, right? That's the first 10. Okay, so what could possibly be a factor of 648? Maybe 64, maybe 216. So let's see. 648 divided by 216. Oh, that worked. Okay, so let's see what 1029 divided by 3 is. 1029 divided by 3 is 343. That's another one. Okay. So we're dividing both of these numbers by 3. And we get 216 over 343. Okay. So that wasn't too bad. So that is A cubed to B cubed is 216 to 343. All right. So that means A to B will be, okay, so this is 1, 2, 3, 4, 5, 6, 6 to 7. So the surface area ratio, right, that's a squared to b squared, will be 36 to 49. 49, not 46. And we did it. All right, hopefully you thought this lesson was not too bad. I know it's got some crazy reducing fractions here, but I gave you the list of perfect cubes, so um, you already know most of your perfect squares, and I think you'll be fine. I'll find out tomorrow. All right, have a good night. Bye.